Hi everyone, this is just an overview of our CFA on 2.2a, Molecular Structure and Properties. Our goal is to be able to model the structure of electron arrangements with Bohr models and Lewis dot diagrams. So you'll need your periodic table to complete this. Let's like that. There we go. And we're going to look at our first problem here. It tells us we have carbon, C, and we have an atomic number of 6 and a mass number of 12. And then it asks us for the number of valence electrons. Well, we know the number of total electrons is going to be 6 because there's no charge here. And so that will be equal to the atomic number or number of protons. And we can also use our periodic table. This is what I'd recommend. And say, hey, if we're looking for valence electrons, we know that each of the elements in this column has one valence electron, 2 valence electrons, 3, 4, 5, 6, 7, and 8, except helium, which has 2 valence electrons. It has a full shell with 2 electrons. And so probably the easiest way is to start to recognize and say like, hey, anything in this column is going to have 4 valence electrons. So carbon will have, then, put that up there, 4 valence electrons. And valence electrons are just those electrons in the outermost shell. And then the Bohr model, we will start by drawing our nucleus with our number of protons, which is 6. How do we determine our number of neutrons? Our neutrons, it's going to be 12 minus 6, right? Our mass number minus our atomic number will give us our number of neutrons, which is also 6. These don't have to be equal. They're often numbers that are close to each other, but they won't always be the same number. And then we draw our first inner shell with 2 valence electrons. And then 1, 2, 3, 4 valence electrons. And then we check, we do, 4 valence electrons, 4 electrons in the outer shell, and total number of electrons is 6, which is equal to the number of protons. So that's good. So total electrons equals 6. And that adds up. So there we go. Now, the big difference between the Bohr model and the Lewis dot diagram is that the Lewis dot diagram only shows valence electrons. So it doesn't have the total number, only the outer electrons. So we would say carbon. We put the symbol for the element, and then we draw 1, 2, 3, 4 valence electrons. Now, it doesn't matter necessarily if you go clockwise or counterclockwise in this, but you do want to give 1 electron kind of in each area before you start pairing them up. So that would be the best model for carbon for the Lewis dot diagram. Chlorine is up here. Let's look at that. And we can see chlorine has 17 protons, and then this is its mass number, so atomic number, mass number, how many valence electrons. I'm going to find chlorine here on the periodic table, and as you get going, right, you'll be able to find your elements a little bit faster as you get used to using this every day. And we can see, oh, we have 7 valence electrons here. It would only need 1 more valence electron to have a full shell. And so we'll write down here 7 valence electrons. Total electrons would be 17. You don't have to write that, but that's going to help us when we do our Bohr diagram. And we know that because there's no charge here for chlorine. And so the number of electrons and protons has to be equal. And we'll draw a smaller nucleus because I'm going to have more levels here, more shells here, with 17 protons. Okay. And then we would say, what's our mass number going to be? We would say 35 minus 17 gives us 18. Right? So mass number would be 35. Subtract the atomic number. That means we have 18 neutrons. Our inner shell, we fill our inner shell first, and it can only hold 2 electrons. Our next one can hold 8. 1, 2, 3, 4, 5, 6, 7, 8. That's not quite enough. And if I look at my periodic table, I know I'm going to need 1, 2, 3 shells for my Bohr diagram because chlorine here is in that third period. So I'm going to have 3. So now I'm up to 10 electrons, but I need 17. So that means I need 7 more here. 1, 2, 3, 4, 5, 6, 7. 7 valence electrons in that outer shell. All right, look up there. So I went 1, 2, 3, 4, 5, 6, 7. 7 valence electrons. Now my Lewis dot diagram is only going to show my valence electrons. So I'm just going to have 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. And that's an easy way to determine how many valence electrons there are without having to draw lots of circles and things like that. Okay, so the next one here, we are given a Bohr diagram and we're supposed to be identifying what element it is. So I'm going to look and see what element has 12 protons. And it looks like magnesium has 12 protons, so this must be magnesium. I'm going to write magnesium, 12 protons. And it looks like there's 12 neutrons, so a mass number of 24. So our mass number is going to be our protons plus our neutrons, 12 plus 12. How many valence electrons are there going to be? I'm going to look at my column and see, oh, it's right here in this column 2, so it must have 2 valence electrons. Put that up there. We don't need to do a Bohr diagram, but we can check and see like, oh yeah, it looks like 2 valence electrons. So that's another way we could have determined how many valence electrons we had. Total electrons, which we don't need to put, are going to be equal to 12. And our Lewis dot structure is just, or our Lewis dot diagram is just going to have our valence electrons. 1, 2. And we're not pairing those yet because we want 1 electron on each side before we start pairing them. The exception to that would be helium. Helium and hydrogen are always a little bit weird, where we would draw those paired. All right, last one, model of a fluorine atom, Bohr model of a fluorine atom, and then the ion. I will do that on the next video here because I'm running out of time.